The key theme running through the last few presentations is that the accuracy of eyewitnesses' memory can be unreliable. So, is there any way in which we can differentiate between an accurate memory and an inaccurate one? Well, one possible indicator of an eyewitness's accuracy is their level of confidence. So, if an eyewitness says that they are absolutely, definitely sure that a suspect is the criminal, then presumably this judgment is likely to be more accurate than another eyewitness who says that the suspect could be the criminal, but they're not completely certain. In fact, some have argued that the confidence an eyewitness displays is the most important factor in whether jurors and criminal justice professionals believe their testimony or not. This is backed up by behavioral data showing a very strong relationship between the confidence shown by a witness and whether they're considered to be reliable by both lay people and legal professionals. In fact, in several Australian jurisdictions, judges will actually cite witness confidence as an example of an indicator of witness credibility in their instructions to the jury. So, is this all true? To what extent does an eyewitness's confidence actually predict their accuracy? Psychologists have investigated this question, and while it's not true that confidence tells you literally nothing about accuracy, the relationship has turned out to be much more complicated than previously thought. To understand this, I'm going to need to explain what a correlation coefficient is. A correlation coefficient is a statistic that measures the strength of a relationship between two variables. It's easiest to explain using a graph. On this scatter plot, the range on the vertical axis shows all possible levels of an eyewitness's confidence. No confidence at the bottom to complete confidence at the top. The horizontal axis shows two categories of accuracy. Inaccurate, they got the identification wrong, and accurate, they got the identification correct. So, first of all, let's show the situation where confidence is a perfect predictor of accuracy. Each dot I'm going to draw here is a different eyewitness. The first eyewitness is 100% confident and made a correct identification. The second eyewitness is completely lacking in confidence and turns out to be giving us an inaccurate identification. And so on with other eyewitnesses who stand right on top of either one of the first two dots. So in this first example, we have no overlap between the accurate and inaccurate eyewitnesses. All of the accurate eyewitnesses have the same level of confidence, which was 100%, and all of the inaccurate eyewitnesses also have the same level of confidence, but for them it was 0%. Here, confidence is a perfect predictor of accuracy, and in this situation, the correlation coefficient will be at its maximum of 1, denoting a perfect relationship between the two variables, where knowing an eyewitness's confidence allows you to know without any doubt whether their identification is accurate or not. If this happened in real life, you would always be able to know whether to believe an eyewitness or not based entirely on whether they were high or low in confidence. Now let's see what other rather more plausible outcomes might look like. Now we have some variation in confidence levels where this scatter means that the correlation won't quite be technically a perfect one. However, there's still no overlap between the confidence levels of the accurate and inaccurate eyewitnesses. And so, in principle, as long as we knew in advance the point at which the confidence level flipped from yielding inaccurate answers to accurate ones, we could still tell with 100% certainty whether an eyewitness could be believed or not, based entirely on their level of confidence. The correlation coefficient for this data would be about 0.9. Now, in this example, we have overlap. where some of our reliable eyewitnesses are actually less confident than some of our unreliable eyewitnesses. So in this particular situation, the correlation coefficient would be about 0.7, rather less than perfect. So eyewitness confidence gives us some indication of their accuracy, but it's also going to be misleading some of the time. Now, the overlap is much more severe. It's still the case that on average, the accurate eyewitnesses are more confident than the inaccurate eyewitnesses. But if we rely on confidence to tell us whether we believe an individual eyewitness or not, then we're going to be misled an awful lot of the time. In this scenario, confidence is an unreliable indicator of whether an individual eyewitness is accurate or not. And finally, here we have a zero correlation between confidence and accuracy, the case where confidence tells us absolutely nothing whatsoever about whether to believe our eyewitnesses or not. The two variables are completely independent of one another. So that's the range of relationships we could get. In the next presentation, we'll find out which of these relationships between accuracy and confidence is the reality.